everybody please stand and welcome the entering class of PhD graduate students at Case Western Reserve University School of Medicine. Please be seated. Good afternoon, students, faculty, parents, family, and friends. Welcome to Seeds of Discovery, our 5th annual PhD White Lab Coat Ceremony at Case Western Reserve University. I'm Paul MacDonald, the Associate Dean for Graduate Education in the School of Medicine, and I'm thrilled to have you all here enjoying this beautiful day in Cleveland. This is our 5th year for this event, and so far, we have always been blessed with good weather. The sun literally shines on our PhD students every year. The purpose of Seeds of Discovery is to formally recognize and welcome the entering class of PhD students as they begin their studies and training in biomedical research at the School of Medicine. While hundreds of white lab coat ceremonies are held throughout the U.S. medical schools each year to recognize their medical students, Case Western Reserve University is one of only a handful of schools that also recognize their PhD students in this way. The title, Seeds of Discovery, is taken from a quote that is attributed to a famous 19th century American physicist, Joseph Henry. The seeds of great discovery are constantly floating around us, but they only take root in minds well prepared to receive them. This Seeds of Discovery ceremony proclaims the value that our PhD students bring to the School of Medicine and the significance of these young scientists in fulfilling the research mission of the School of Medicine and indeed the overall mission of the entire university. It also affirms our commitment to these students to provide the best educational approaches, training experiences, and individualized skill development that will prepare your minds not only for uncovering groundbreaking biomedical research discoveries, but to become the future leaders of academic, industrial, and other research-intensive professions. Thus, Seeds of Discovery serves to welcome you as our junior colleagues into the biomedical research profession. This is your first step on the path to this profession. Webster defines profession as a calling requiring specialized knowledge and often long and intensive academic preparation. You have all been called at some level to this research profession. Your undergraduate and summer research experiences in state-of-the-art labs across the country likely ignited those early flames and drove your early passions for research and uncovering new insights into complex biological processes. Your dedication, your work ethic, and your sacrifices in those early years have resulted in your admission to our PhD programs. And now that you are here, you will continue to sacrifice, work hard, and study intensively, but it is absolutely essential that our faculty and administration nurtures those early seeds of curiosity and excitement, allow them to sprout by providing modern educational experiences, cutting-edge research training, and sound, thoughtful, compassionate, meaningful mentoring. And finally, to promote the growth and development of those seedlings into mature research scientists by providing the professional skills and leadership experiences needed in today's challenging national research climate. And so we are here to celebrate you and the beginning of your journey into this profession and to support your pursuit of this calling. This is an exciting day for me, and I hope for you. It is for the School of Medicine as well. I love this event. I love this day. It is a day to truly enjoy and celebrate the students, the faculty, the staff, and the leaders of this amazing educational and research enterprise that is Case Western Reserve University. This is a day to relish all of the positives, reflect on all of the great accomplishments of our past and current students, and to absorb all of the new energy, enthusiasm, ideas, and contributions that you, our students, will all bring to our classrooms, our laboratories, scientific conferences, and social gatherings. Importantly, we are here together and now to celebrate this group of PhD students, a truly international, diverse, and accomplished collection of young scholars. There are a total of 67 students entering PhD programs in the School of Medicine this year, 53 PhD students, and 14 students from the Medical Scientist Training Program, or the dual MD-PhD degree track. These 14 students are currently entering their third year or the first year of their PhD training, and so we celebrate and recognize them as well. Of these 67 students, 52% are male. They come from 9 different countries, including China, India, Saudi Arabia, Iran, Colombia, Uganda, Portugal, Nicaragua, and the US. You come from 19 different states, including California, South Carolina, Missouri, Washington, Massachusetts, Connecticut, New York, New Jersey, Pennsylvania, Maryland, and Tennessee, just to name a few. 30% of you are from the great state of Ohio, and 7 from our own nationally recognized undergraduate program at Case Western Reserve. You come to us from other highly prestigious undergraduate institutions, including Harvard, Berkeley, Princeton, Washington University, Cornell, Chicago, and others. The richness and diversity of this group of entering PhD students will add tremendous value to the intellectual environment here in the School of Medicine, and we are all looking forward to reaping that harvest. This unique, multicultural, and robust scholarly atmosphere at CWRU is a direct result of the leadership of this institution, the School of Medicine, and the individual PhD degree granting departments and programs. Their forward-thinking approaches and responsiveness to the needs of our students in this continually evolving and often very challenging national biomedical research landscape are major assets to this institution. I wanted to specifically welcome and thank our institutional and School of Medicine administrative leaders that are in attendance today for their strong support of Seeds of Discovery, and especially recognize Dr. Mark Chance, Vice Dean for Research in the School of Medicine, who is out there somewhere. I want to recognize all of the chairs, graduate program directors that are attending and participating in Seeds of Discovery. These are some of the greatest minds in the nation and some of the busiest people in the world. They are out there sitting amongst their students and will help them into their new lab coats in a few moments. The symbolism here is obvious, but the reality is these program leaders care deeply about our students, their progression through the various programs, and they are committed to their success at CWRU and beyond. I want to welcome the faculty that are in attendance today. Your dedication, mentorship, enthusiasm, and passion for research are key ingredients nurturing these young scientists, and they are instrumental for their continued growth and development. Finally, I wanted to take a moment to again welcome and recognize the parents and family members, partners and friends that are here with us today, as well as those that were unable to attend. We had over 100 in attendance at the family and guest luncheon today, some of them traveling as far away as Wisconsin, New York, New Hampshire, and New Jersey. I think we broke a record, though, with Rita Avalar. Her parents traveled all the way from Portugal to be with us to celebrate here today. We also broke another record with the Rashans, who brought 11 family members today, aged 4 to 68. So welcome to you as well. We got to know the families a little better, and they also heard from many of our brightest PhD students about what their students will be experiencing throughout their PhD training period. Your students would not be here without your continual lifelong support, encouragement, and love. So I'd like all of the parents, family, partners, friends of the students to please stand up and be recognized by us all. I began this session with a quote from a 19th century physicist, and I wanted to end with a quote from a modern day physicist. I love the quote by Stephen Hawking that ended the movie, The Theory of Everything. In reflecting on his passions for understanding the origins and the expansion of the universe, as well as his lifelong battle with ALS, or Lou Gehrig's disease, Stephen Hawking said, "It is clear that we are just an advanced breed of primates on a minor planet orbiting around a very average star in the outer suburb of one of amongst 100 billion galaxies. But ever since the dawn of civilization, people have craved for an understanding of the underlying order of the world. There ought to be something very special about the boundary conditions of the universe. And what can be more special than there is no boundary, and there should be no boundary to human endeavor?" I hope your experience here at Case Western Reserve is filled with success, and that your life journey is not limited by boundaries that you or others might try to impose along the way. Everything is possible. Again, a final welcome to everybody attending this ceremony. I wish you a grand and rewarding and memorable experience today. Thank you. I am pleased to introduce this year's Seeds of Discovery keynote speaker. Dr. Walter Boron is an international expert on how cells regulate pH as well as ion and gas transport across biological membranes. He has received multitude awards for his research and service, culminating in his recent election to the prestigious National Academy of Medicine. Dr. Boron is the current Secretary General of the International Union of Physiological Sciences and is internationally recognized as the co-editor of the leading medical physiology textbook in the world, commonly referred to as Boron and Bullpeep. Ladies and gentlemen, please join me in welcoming Dr. Walter Boron, the Myers-Scarpa Professor and Chair of the Department of Physiology and Biophysics and the Executive Director of PhD programs at Case.
Well, thank you very much, Paul. And my dear newest younger colleagues, good afternoon. And by new dearest younger colleagues, I mean our new PhD students who are now part of our profession in the area of research in biomedical science. You are indeed our younger colleagues, although at the beginning of your journeys. And I'd like to say hello as well. Welcome to the parents, the friends, and significant others of our newest younger colleagues. Good afternoon. Welcome to Cleveland. Welcome to Case Western Reserve. I've been asked to make a few observations on research, and like to begin by saying that in terms of a research scientist, I think the biggest thing that you can do during your career is to change the way that people think. And I think if you can change the way that people think, we can regard this as success. And then I would like to just speculate a little bit on what it takes to achieve success. Well, you might start off, it begins with good looks and a high IQ, or at least one of the two. But a high IQ is not good enough to achieve success. I'm sure there's plenty of people out in this room that have an IQ high enough to be able to do research that is worthy of a Nobel Prize. I'm sure that that's possible based on a high IQ, but that's not enough. In order to succeed, one has to have, of course, luck, but one has to work hard. One has to learn how to write well. You have to learn how to speak clearly. You have to learn how to interact with your colleagues in a friendly way. You have to learn how to inspire those around you. You have to learn how to listen to those around you. You have to learn how to read widely and read with comprehension. You have to understand when you're reading something, whether it's right or whether it's wrong. You have to be creative. You have to have courage, and I'll explain what I mean by that later. And you have to have good judgment. Among all of this long litany of qualities, and I'm sure I've left out some important ones, but among this long litany of qualities, many of these you can't control. These are God-given traits, but one of them that you can control is your ability to work hard. Work often separates the people who succeed and the people who do not succeed. I just like to take a moment to think of where I was a week ago. I was in Kuala Lumpur, Malaysia, and I was there for something called the Intermedical School Physiology Quiz. Believe it or not, they have a 2-day event, 103 medical schools represented, starting on the west side from India, going all the way out to Japan, from Mongolia and China, going all the way south to Sydney, Australia. 103 teams, each consisting of 5 medical students and a couple of faculty advisors. The enthusiasm on the ground was just unbelievable. The first day of the quiz, all of the teams were taking a written exam. It was computer scored, and that sorted out the top 100, out of the 103, it sorted out the 48 eighth finalists, and these 48 teams then went through a series of oral examinations. I was one of the judges in the oral exam, and through several rounds, 8th finals, quarterfinals, semifinals, and finals, we finally arrived at a winner. Among the 4 teams that were finalists, 2 were from Sri Lanka, and the winners were from Sri Lanka. Of all of the teams that were there that could have won this prize, of 103 medical schools, it was not from a wealthy city in Japan or China or Sydney, Australia. It was from a school in Sri Lanka. I put to you that those students worked very, very hard to get to where they were, and they answered some very tough questions. And if you're going to succeed in this business, you're going to have to work as hard as those Sri Lankan medical students, because we are in a global economy. You're not trying to compete with the neighbor next to you here in Cleveland, nor are you even competing with somebody in New York City or San Francisco or Los Angeles or Tokyo. You're competing with people all over the world. Somebody around the world is working on your research problem at any moment of any day in the 24-hour cycle that the Earth is spinning around the world. So keep in mind, you have to work hard. So you become successful by changing the way that people think. And in order to change the way that people think, you have to make a discovery. And what is a discovery? I would argue that a discovery is something that happens almost always by accident. You're doing an experiment which seems very often to be trivial. You do an experiment and you expect to get X, but the result isn't X, it's Y. And then you ask, why? Why are you getting this aberrant result? I think that about 90% of the time there was a mistake that was made. And you need to have the creativity and you need to have the judgment to look at that result and ferret through all of the possibilities and figure out whether you indeed made a mistake, which is the most likely outcome. But then there's a 1 chance in 10, I would estimate, that your aberrant result is actually correct. And now that it's correct, what are you going to do about it? Again, you have to have the creativity to chase down what exactly it means. And if you're right, and if you really have changed the way that people think, if you actually have initiated a paradigm shift, now you've got to have the courage to see it through, because not everybody's going to agree with you. Not everybody's going to be happy that you've just made this discovery, because now all of a sudden you have the potential of being famous, and they're not. There's going to be jealousy. There's going to be all sorts of people who are going to be trying to challenge you, which is a good thing, because no paradigm shift should go unchallenged. But you're going to have the courage and the creativity to stick with it, think of new experiments, to test your hypothesis. It's important that you don't try to prove yourself right. If you try to prove that your hypothesis is right, you're on the road to destruction. You've got to do everything you possibly can to try to prove yourself wrong. And then, as Sherlock Holmes would have said to Watson, after you've eliminated all of the other possibilities, whatever is left, no matter how unlikely, must be the truth. I don't think that's necessarily true, but you do have to rule out all the other possibilities, and that makes it more likely that what you think is a discovery is actually perhaps coming to fruition. So discoveries are accidents. You do an experiment, maybe it's a control experiment, you try to get X, you get Y, you track it down at something new. Where do you find these discoveries? There's no director of the NIH, there's no dean, there's no deputy dean, there's no program director, there's no chairman of a department, there's no professor, there's no postdoc, there's no graduate student, there's no technician that can predict where the next discovery is coming from. Albert Einstein once said, of course we don't know what we're doing, that's why they call it research. And we can't predict where the discoveries are coming from. Major discoveries are unpredictable, they're unforeseen. If we could foresee them, they would not be discoveries. So they're going to happen by accident. You have to keep your eyes open, because nobody can tell you where they're coming from. A corollary to all of this is beware when a NIH executive, when a dean, when a chairman of a department or a professor decides that this is where you ought to look to make a discovery, because that's not always where the discoveries are made. Discoveries are usually happening by accident, and it happens to smart people working hard and being very careful and showing creativity, courage, and judgment. I'd just like to close by giving an example of a discovery. Back in 1989, a person by the name of Peter Agre, who did some of his training here at Case Western Reserve University, he was an intern and resident at university hospitals. Peter Agre in 1989 at Johns Hopkins University discovered a protein he called CHIP28. The reason it was called 28 is that it weighed 28 kilodaltons, 28,000 units of molecular weight. He didn't know what it meant. He cloned this from the progenitor cells from red blood cells. In 1992, working with others, he figured out that this CHIP28 was in fact the world's first water channel, and he renamed it aquaporin 1. That was in 1992. A few years later, another fellow out in California, using that information about aquaporin 1, cloned aquaporin 4. Aquaporin 1 is all over the body, including red blood cells. Aquaporin 4 is at the blood-brain barrier. It covers about 1/3 of the surface area of the astrocytic end feet that wrap around. If this is a blood vessel in the CNS, in my hand is an astrocytic end foot. Almost every square micron of the brain's vessels are covered by astrocytic end feet, and if you pull that end foot back, 1/3 of that surface area is aquaporin 4. Aquaporin 4 is responsible for the movement of water from the blood into the brain, and then during a model of a stroke, the water moves through the aquaporin 4, causes cerebral edema and severe neurological damage and even death. So in the mid-1990s, somebody cloned the gene that encodes aquaporin 4. Later on, in the late 1990s and early 2000s, they made a knockout mouse and demonstrated that the mouse that lacked aquaporin 4 was resistant to the cerebral edema caused by models of stroke. Interesting. You had a very difficult time killing these animals. Additional work was done in the early 2000s, and then finally in 2007, I collaborated with a colleague to form a new company called Aromics, which started at Yale and then moved here with me to Cleveland. And we, a couple years later, found a small molecule that blocks aquaporin 4. We demonstrated that this small molecule can prevent cerebral edema, or largely prevent cerebral edema in mice and rats, and thereby almost make them impervious to death by stroke due to cerebral edema. And now we're at the point we're ready to submit our materials for an investigational new drug license. This is now in 2017. And the first human safety testing will be done in early 2018, and if we're lucky, and we only have one chance in 6 of being lucky at each step along the way. If we're lucky, in 2024 or so, 35 years after the initial discovery of CHIP28 by Peter Agre, who, by the way, won the Nobel Prize in Chemistry in 2003. So along that way was a Nobel Prize. And it would be 35 years later, if we're lucky, that finally physicians will have that drug in their hand and be able to treat brain swelling during stroke and certain other kinds of diseases. So you, as young PhD students starting your careers, hopefully will make some discoveries, like the discovery that Peter Agre made of aquaporin 1, and perhaps many years down the line, that discovery will be translated and eventually will end up in the clinic helping to save lives. But it's a long, long journey to do that. But it all starts with a discovery. It starts with hard work. It starts with courage, creativity, judgment, and so on. But you're all in the position to be able to do something of that sort. And so I challenge you to begin, as you start your careers now, to begin the process of making such discoveries that could lead perhaps someday to a discovery that makes it to the clinic and helps improve the lives of human patients. So again, to my dear newest younger colleagues, welcome to Case Western Reserve University. Good luck in your careers. I hope to see more of you as we proceed for the next several years, and have a great afternoon and evening as we go through the reception. Thank you.
Thank you very much, Dr. Voron, for those wonderful words. I would like to ask Dr. Mark Chance to please join us on the stage to congratulate the students. Dr. Chance is the Vice Dean for Research here in the School of Medicine. And would the first row please stand to begin awarding of the coats and line up to the left over there. I'll first introduce briefly Dr. George Dubiak, Professor of Physiology and Biophysics and the new Director of the Biomedical Sciences Training Program.
Good afternoon. What you're going to be seeing over the next hour or so are students in multiple disciplines who are interested in many areas of biomedical research. It's about 15 PhD programs that are represented. And our new students interested in these many areas are many times interested in multiple areas of investigation. And so the Biomedical Scientist Training Program, or the BSTP, provides the initial portal of entry, if you will, for when those students were applying to Case Western Reserve University. when they were being interviewed, and most happily when they actually accepted and are now here today. So the BSTP provides a way of students being able to view biomedical research from multiple standpoints. For example, a student might be interested in Alzheimer's disease. And does she want to study that from the perspective of a neuroscientist and maybe consider a PhD in neuroscience? Or she might be interested in it from the perspective of the genetics, genetic predisposition or protection from Alzheimer's disease, and may want to study from the perspective of the Department of Genetics and Genome Sciences. Or she might be interested in studying it as a potential therapeutic target and pursue a PhD perhaps in pharmacology. So the BSTP students are given the opportunity during their first semester here to explore biomedical research from multiple experiences and multiple standpoints. And so we welcome all of these students who are going to be joining us and being able to study their interests from multiple standpoints. A similar type of program is the medical scientist training program that Dr. MacDonald briefly introduced. And these are students who are pursuing both the MD degree and the PhD degree. And I'd like to introduce Dr. Clifford Harding, Chairman of the Department of Pathology and Director of the MD PhD or MSTP training program.
Thank you, George, and welcome everybody. I would just like to say a few brief introductory remarks about the Medical Scientist Training Program. This is a combined degree program in which students work to achieve both the MD and PhD degrees. Our program actually has the distinction of being the first MD PhD combined degree program invented or in existence starting in 1956. We have been continuously training MD PhD students in our medical scientist training program. We've graduated a large number of very accomplished scientists, including 2 Nobel laureates. And so our students are studying with the goal of careers as physician scientists to become the leading physician researchers of tomorrow. It's an arduous path to seek both of these degrees. It's on average a little over 8 years. They start out in the first 2 years taking a combination of medical school courses and graduate school courses and research activities. They then go in for, on average, about 4 years to complete the PhD degree, also doing a little bit of clinical training integrated in that. And then finally come back to medical school and complete that degree. So it's a very committed group of students. As George mentioned with the students in the BSTP, they have a wide range of interests and can choose amongst the PhD programs and can experience a very interdisciplinary type of experience in their training. So I think now I'll turn it over to welcome the new students.
Hi, I'm back again, but this time in the context of being the interim chair of the Department of Biochemistry. By introduction, biochemistry as a discipline diverged from the discipline of physiology back in the 1880s to study the chemistry of physiological systems, and in a more general sense, the chemistry of biological systems. So biochemists study chemical reactions, they study metabolism, that is the chemical reactions that build up to molecules or break molecules down. They study the structure of these molecules at atomic resolution so we could understand how the molecules work in great detail. They're interested in drugs, and they're interested in molecules that become targets for drugs. And so without further ado, our new students. Oh, I don't have
You don't have the list?
I don't have the list.
We need a list.
Gavin Hansen. Gavin Hansen.
Okay. Does somebody have the list?
I just got it on this phone.
It's on the slide. Just read the slide.
Let's read this.
Okay, our first student, Gavin Hansen from the University of Kansas.
The slide is good. Congratulations, Gavin.
Sarah Venus from the University of Cincinnati.
Congratulations, Sarah.
Congratulations. And Xinru Zhang from Harvard University.
Congratulations.
Hello, everyone. My name is Bob Kirsch. I'm the chair of biomedical engineering here at Case, and I'm joined by the vice chair for our graduate program, Nicole Cyberlick. Engineering is defined as the application of science and mathematics to the properties of matter and the sources of energy in nature that are made useful to people. And in biomedical engineering, we apply the engineering techniques such as analysis, instrumentation, and design specifically to problems in biology and medicine. So our students learned advanced engineering techniques within the context of physiology and biology. So I'm here to welcome our PhD students today, our new students. First is Nabil Chowdhury from Washington University in St. Louis.
Welcome. Congratulations.
Next is Andrew Dupuis from Case Western Reserve University.
Congratulations.
Congratulations. Felicia Herr from Case Western Reserve University. Congratulations. Xu Yang Huang from Case Western Reserve University. Congratulations. Mohammed Hadi Karami from KN Tusi University of Technology. There we go.
Congratulations.
Congratulations. Welcome. Morgan Lorkowski from Case Western Reserve University.
Morgan, congratulations.
Welcome. Emily Mugler from University of Virginia.
Congratulations, Emily.
Welcome. Yes. Siddhartha Nanda from the University of Alabama at Birmingham.
Congratulations.
Welcome. Ruchika from the Punjab Technical University.
Congratulations.
Lu Wong, Washington University in St. Louis.
Welcome. Congratulations.
Welcome. Kathleen Young from Cornell University.
Congratulations.
Good afternoon. I'm Lee Lee. I'm a director for the Clinical Trans Science program, PhD program. Together with my colleague Jim Spilsberg, we co-direct the program. Clinical Trans Science represents the field of knowledge that conducts and speeds up clinical research work from the lab bench to the patient bedside and to the community. Students in the program are trained in the theory and practice of clinical translational science in order to make significant clinical discoveries and to move this discovery towards treatment, practice, and policies. Now I'm introduce our student this year. First student, Zaneb Alba from King Abdulaziz University, Saudi Arabia.
Congratulations and welcome.
Thank you.
Second student, Aditya Hari from Kannur Medical College, India.
Congratulations and welcome.
Okay, thanks. Uriel Kim from University of Southern California. Sandra Silver from University Bucaramanga, Colombia.
Congratulations and welcome.
Congratulations.
Thank you.
Thanks.
Hello, everyone. I'm Tony Wynshaw-Boris, and I'm the chair of the Department of Genetics and Genome Sciences. And I'm joined with the directors of the graduate program, Dr. Zhua Lu and Ann Matthews, who's also the director of our genetic counseling graduate program. So genetics is the study of heredity and inherited characteristics. We're genome sciences because now in the post-genome era, we don't have to just look at traits and genes one at a time. We can look at all of them at the same time. And the study in my department of these variations are both in health and disease using model organisms straight through to the clinic because we also have clinical genetics in our department. And it's my pleasure to welcome our new students in the department. First, Catherine N. Johnson from Woodford College.
Congratulations, welcome.
Yes, welcome. Congratulations. Next is Ritesh K.C. from Virginia Polytechnic Institute.
Welcome. Congratulations.
Congratulations. Leanne Main from Wittenberg University.
Congratulations, welcome.
Welcome. Alec Puranjape from University of Washington.
Welcome. Congratulations.
Welcome, Alec. Kelsey Pollock from Towson University. Shanshan Zhang from Harbin Medical University.
Congratulations, welcome.
Yes, welcome.
Good afternoon. My name is Alan Levine. I'm the Graduate Program Director for the Department of Molecular Biology and Microbiology. I'm here representing our chair, Jonathan Karn, who sends his regrets. His travel made him unable to attend today, but he wishes everyone in this room the very best. I'm joined today by Dr. Alan Tartikoff, who is the director of the cell biology program within our department. So our department has 3 PhD programs. One, the Molecular Biology and Microbiology department has a program called, very creatively, Molecular Biology and Microbiology. And in this program, students are brought together to ask the questions of what are the elements of gene expression that regulate physiological and pathological events, and also study a number of microbes, one of which allows Case Western Reserve to be world famous, is to study tuberculosis. The second program within our department is the cell biology program. Cell biology is the study of what are the inner workings of the human, or mostly eukaryotic cells. How do those proteins and the suborganelles within that cell allow the cell to function in a physiological and pathological state? And finally, we have a molecular virology program, which is the study of viruses, as you might predict. And again, Case Western should be proud of the fact that they are a worldwide leader in the study of HIV research. It's a pleasure now to introduce our students. The first is Frederick Kyoto from Kambabo University in Uganda.
Welcome and congratulations. Thank you.
We welcome Andrew Mack from the University of Washington. Parth Mahmudar from Belmont University. Rachel Sabel from University of New Hampshire.
Rachel, congratulations and welcome.
Good luck. Catherine Umfred Wilson from Rochester Institute of Technology.
Congratulations. Good luck. Thank you, Alan.
Thank you, thank you.
Hi, my name is Jonathan Smith, and I'm chairman of the Department of Molecular Medicine, but I'm also the program director. And Paul MacDonald's going to help me fill in for Christine Moravec, who couldn't make it today. Our program, I'm really happy to welcome our 11th class into our program. And our program is housed at the Cleveland Clinic with the goal of training the next generation of translational researchers. And we introduce medical knowledge into our curriculum so that our students can feel comfortable collaborating with physicians and teams, multidisciplinary teams, to make discoveries about the causes and cures of human diseases. And I am always inspired by the transition that our students make when they enter young here today, and just another year and a half or 2 years down the road, they're really experts in their area of research, and they're real scientists at that point in time. And I've made a goal. We all watched the eclipse earlier this week in Cleveland, and in 2024, 7 years from now, when the next eclipse rolls through, these will all be long graduated with their PhD. So. First, I'm going to call Abigail Dooley from Rensselaer Polytechnic Institute. Shuai Fu from Sichuan Agricultural University. Congratulations. Christel Pegba from Savannah State University. Congratulations. Gabrielle May from Walsh University. Thank you. Lucas Osborne from Michigan State University. Congratulations. Dean Pontius from Case Western Reserve University. Congratulations. And Katie Troike from Ohio University. Congratulations.
Good afternoon, everyone. My name is Evan Daenerys, and I'm the interim chair of the Department of Neuroscience, and I'm joined by our graduate program director, Heather Breuer. Understanding normal brain function is one of the most exciting frontiers in science today. Research in the neuroscience department is focused on understanding how different kinds of neural cells are generated, how synapses and neural circuits are assembled, and how they function to give rise to complex behaviors. Our faculty are also working to develop new ways to restore function of circuits in the brain, spinal cord, and peripheral nervous system that have been disabled by disease, injury, or environmental insults. Today, I have the pleasure to introduce our first student, who is Preethi Sridharan. And Preethi is from the Carnegie Mellon University. The next student is Anthony R. Sloan from Westminster College. The next student is Aaron D. Talsma from the University of Michigan. The next student is Alicia N. Vagnozzi from Northwestern University. And the final student is Peng Zhang from Zhejiang Minzu University.
Welcome, everyone. My name is Hope Arkukas, and I am the interim chair of the Department of Nutrition. And I welcome with me today to assist Dr. Shell Thompson. She is a nutritional epidemiologist and also the director of the master's programs. The Department of Nutrition, really, when you think about nutrition from cell to system, impacts life, well-being, disease, course of disease, and as such, our researchers are engaged with all different types of research approaches. From cell to animal, we have human clinical trials ongoing, we have nutritional epidemiology, we have systems biology, proteomics, a wide array of research, and we also are home to the Center for Proteomics and Bioinformatics. And so it's my pleasure to congratulate Elizabeth Zuniga from Case Western Reserve.
I'm Cliff Harding, the chair of the Department of Pathology, and I'm here to introduce students joining the Pathology PhD program. And with me here is Xiangwei Zhu. He's the director of the Pathology graduate program. First, just a few words about pathology as a field. Pathology literally is the study of disease. So it is a field in which we apply basic science approaches to translational problems. Our program does have focus areas in certain fields of science, primarily immunology. In fact, we have 3 different constituent training programs within the PhD program in pathology. The immunology training program, this focuses on the mechanisms of the immune system and its role in various disorders, including infectious disease, its application in immunotherapy and other areas. The second constituent training program is the cancer biology training program. So research in that field is addressing the mechanisms of cancer and the development of therapeutics. And finally, the third training program within pathology is the molecular and cellular basis of disease program, which is addressing a diverse set of scientific fields, including neurodegenerative disease and others. It's a fairly interdepartmental program, includes participation by faculty, not only in pathology, but many other fields. So I'd now like to welcome the students. And the first one is Marwa Al-Bakri from Taiba University. The next student is Anne Alma from McCary University.
Could you introduce your graduate program director? Welcome, congratulations.
The next student is Leon Fan from the University of Pittsburgh. The next student is Adrian Gomez Nguyen from the University of Chicago. Welcome again, Adrian. The next student is Nathaniel Robinson, did his undergraduate work at The Ohio State University. The next student is Christy Roshan from Central State University. Welcome. Next is Quentin Watson from the University of California, Berkeley.
Welcome, congratulations.
Thank you. Welcome, nice to see you again. And finally, Bowen Zhou from Princeton University. And I'd like now to introduce Dr. John Meal, representing the Department of Pharmacology's graduate program.
I'm John Meal, Vice Chair of Pharmacology, representing Chris Palczewski, and with me is Marvin Neiman, the co-director of the Molecular Therapeutics Training Program. Pharmacology is an integrative research discipline that builds upon foundations in chemistry, biochemistry, cell biology, systems physiology, and pathology in order to focus on novel drug targets and to understand the mechanisms of drug efficacy and toxicity. Students who graduate with a PhD in pharmacology are set up for many different and wide opportunities for careers. Our department has enjoyed a rich tradition highlighted by Nobel Prizes to 3 former members of the department, faculty, and students. Earl Sutherland for discovery of cyclic AMP, Al Gilman for the G protein coupled signaling, and Fred Murad for nitric oxide signaling. Our mission is to continue this tradition of excellence, and we look to our students to lead that effort. And now I'd like to welcome our newest future stars, starting with Rita Avalar, University of Beira Interior, Portugal. And Brianna Bauer from the College of Worcester, Ohio. And next we have Walter Boron for the Department of Physiology and Biophysics.
Thank you very much. So I'm the chairman of Physiology and Biophysics. What is physiology and what is biophysics? In Chinese and in Japanese, the 3 characters that represent physiology literally mean the study of the philosophy of life. I guess that's a lot to swallow in one mouthful. In the United States, we would define physiology as the study of function. Biophysics is the application of physical principles to biology, and these physical principles can include things like electromagnetism, optics, mechanics, and indeed X-rays for doing X-ray crystallography. Together, physiology and biophysics here in our department is rather unique. There's probably only a few departments in the world that can truly lay claim to studying function from the level of individual molecules, through clusters of molecules, through portions of cells, to whole living cells, to tissues, to organ systems, to indeed the entire organism, which can then be modified using tools of molecular genetics. So physiology is intrinsically an integrative science going from atoms to the whole animal, and it also is tending to be quite quantitative. So the physiology part and the biophysics part both have that in common with one another. The department has 3 major areas of interest. Programmatically, we study neurobiology or neurophysiology, especially neurodegenerative diseases. We study the cardiovascular system, and we study the kidney or the renal system. Along with me today is Corey Smith, who's our graduate program director. And so Corey, might we welcome our 2 new graduate students. First, Haiming Bai from Ocean University of China. and Sarah Taki from the Medical School of Isfahan. Good to have you with us. Congratulations. Congratulations. And now I'd like to introduce the next chair from the Department of Population and Quantitative Health Sciences, Jonathan Haynes. Jonathan?
Hi, I'm Jonathan Haynes. I'm the chair of the newly renamed Department of Population and Quantitative Health Sciences, which with a name like that pretty much allows us to do pretty much whatever we want. Our goal is to integrate a lot of different disciplines with a focus on computational, biostatistical, and analytical approaches to human health and human disease, and try to bring that information through from cells to society, from understanding molecular processes to being able to deliver that to community and population health. So we have expertise in bioinformatics, in biostatistics, in epidemiology, in genetics, population genetics, and how genetics affects the populations of the United States and of the world, and of population and community health and health services research. So we have a very broad opportunity for our students to learn a lot of different things and to integrate that. And then with that, I would like to introduce our first student, Gwendolyn Donnelly from The Ohio State University. Yo-Jun Lee from Nankai University. Roberto Martinez from Universidad Nacional Autónoma de Nicaragua. And Elena Misica from The Ohio State University. And I forgot to introduce Dr. Scott Williams, who is our Director of Graduate Studies. And with that, I will introduce Mark Chance, who is the Director of the program in Systems Biology and Bioinformatics.
That's right. So systems biology is one of the newest disciplines represented today. It was actually invented 50 years ago at Case Western Reserve University in an attempt to provide mathematical modeling for a number of metabolic reactions that were emerging at that time. And then what happened to it is it promptly fell out of sight and disappeared. We didn't have the data 50 years ago. Fast forward to 2017, and we're awash in data. An individual scientist doesn't produce 100 times more data than they used to, or 1,000 times, it's 1,000,000 times, it's 100 million times more data. And the science of systems biology helps with the data for all of those people you've heard about to provide predictive and mechanistic models for how does a molecule function, how does a cell function, how does a tissue function, even how ultimately the whole organism functions. So it's a big task. Welcome today David Ladowski, who is our graduate program director, and our student entering the PhD this year is Bushra Al-Ghamdi from King Abdulaziz University, Saudi Arabia. And now I turn it back over to Dr. MacDonald.
Okay, that coat rack is empty. Would all of the students, chairs, directors, please stand up so that you can be recognized as a group? Okay, we're nearing the end, and this is one of my favorite parts. It's my great pleasure to introduce the final speaker for today. We began this tradition at our second Seeds of Discovery event in 2014, and I heard from a recent Faculty Senate chair that if you do something 2 years in a row, you can call it a tradition. So our tradition at Seeds of Discovery is that the final speaker is one of you. It's one of your own. Each year, we select a student that went through last year's Seeds of Discovery to close the ceremony. Ibrahim Arabi received his BS in biology from the University of New Haven in Connecticut, where he began his biomedical research training in a laboratory at Yale University and then later at Pittsburgh, working on the general topic of acute pancreatitis. 10 years, 20 publications, 6 of them first authors, more than 25 published abstracts, 4 co-authored book chapters, and dozens of presentations later, Abe decided to pursue a PhD. CWRU was lucky enough to land him. To categorize Abe as a non-traditional student is a complete understatement. He is an outstanding, imaginative, and innovative young scientist with a passion for research. He's currently studying in Dr. Sandy Markowitz's lab, working on colon cancer. Ladies and gentlemen, Abe Arabi, second-year PhD student in genetics and genome sciences.
Thank you, Dr. Markowitz. Thank you, Dr. MacDonald. Good afternoon. There are really only 3 things I want to tell you before you leave this room and embark on a journey to the campus bookstore, where your parents will buy you a lifetime supply of university embroidered loungewear. 3 things, that's all. The first thing is to assume you know nothing. Better yet, from now on, whenever you have downtime, continually recite in an audible voice, "I know nothing, I know nothing." This will draw unwanted glares, but will also remind you of a universal truth, that real knowledge is to know the extent of one's ignorance. To admit you know nothing is a beautiful and humbling sentiment. When I entered graduate school, I had nearly a decade of academic research experience. My name was attached to over 20 original scientific publications, and I had established a sound reputation in the world of pancreatic research. I came to graduate school assuming I knew something, only to realize that something was relatively nothing. This realization should be used as fuel, which drives your unabashed willingness to ask questions constantly and thoughtfully. Fight every instinct that tells you your pride is more important than an experience to learn. To assume you know nothing will allow you to see the world with a child's wonderment and a scholar's perspective. The second thing is to find your gift, realize you love it, and pursue it viciously. This is a hard one, but let me give you a simple example. My grandfather was born at the height of the Depression in the steel capital of the world. His destiny should have been to work in a combustion plant, helping to produce the world's supply of iron alloy. Instead, he went to a university at a time when college degrees were scarce. Following his gifts instead of an expectation led him down a different path. To this day, he makes the trip every morning to his university lab where he studies earthquakes. Next year, he'll be 90. In some rare instances, a person's true gift intersects seamlessly with their true love. Most of us, however, must work tirelessly at excavating ourselves, digging through our troves of talents and ambitions before we can clearly identify our undisputable gift. My point is, all of us are born with a gift, yet most of us live our entire lives never really understanding what it is. My advice to you is keep digging. And when you find it, realize you love it. After all, someone or thing was nice enough to give it to you in the first place. From there, make it your life's goal to pursue it without regret. Acting upon our gifts is the greatest insurance policy for an exciting life. The third thing is to understand the myth of the mountaintop and the reality of climbing. In 2004, I completed my first semester of college and found myself in an unfamiliar situation. I was flunking school. In my panic, I stood still. Time went by, and my second semester wasn't much better. So I made a decision to stop spectating and start climbing. Inch by inch, I began crawling my way to what I hoped would be the mountaintop, the realization of all my dreams. Slowly but surely, opportunities came knocking. Long story short, let me just say, I've learned some important lessons since then. I've learned that the view from the bottom is overwhelming, and that the hardest part of any climb is the first step. Oftentimes, it's hard to know what that step should be, or in which direction. For me, starting the climb was half the battle. I've also learned that in the real world, no one cares where you've been, or how far you've traveled. What matters is where you are in the present and what you can contribute now. Last March, my PhD advisor wrote me an outstanding letter of recommendation for a grant I was applying for. We had only known each other for a few months, yet the letter sounded like we were father and son. In reply, and out of gratitude, I sent him the following email. Thank you, Dr. Markowitz, for this tremendous letter. I'm truly flattered. Your support and encouragement mean a great deal. To which he replied, Hi, Abe. No thanks needed. After all, now you have to live up to the letter. I didn't interpret his reply as a threat, but rather an affirmation that what's past is past. It was also a reminder that climbing is constant. You see, there is no summit. The mountaintop is a myth. The only reality is that climbing lasts forever. The sooner you can come to this realization, the easier the climbing part will be. I'd encourage all of you to find a mentor who is willing to endorse you publicly and still push you privately. Now, before I go, I want to say something about what it means to be a student of scholarly thought. Be warned, you are entering a bubble. Inside this bubble is a world based on facts and reasoning and logic. Outside the bubble lives a post-fact world. With this white coat, you are taking an unwritten oath to uphold the virtue of facts and dispel the nonsense of propaganda, be it scientific or otherwise. As you embark on this journey, you will forever be seen as an ambassador of truth in an often fact-free world. The title of PhD student will indelibly make you defenders of that which is educated. Outside the bubble, you will hear people say things like, if we evolved from monkeys, then why are there still monkeys? You will read things like vaccines cause autism. You will listen to politicians say, global warming is a hoax. From now on, when you encounter these sentiments, it is your responsibility to retaliate with truth. Your acceptance into the upper echelon of academia bears weight. Complacency to non-truths will often be viewed as an endorsement of those non-truths. As an intellectual, what you say matters. What you don't say matters more. So there you have it. That's it. You're ready for graduate school. Oh yeah, I almost forgot one thing. Call your mother. After all, she was nice enough to buy you all that university embroidered loungewear. Thank you.
Okay, before we begin our procession out, I just wanted to say a final word of congratulations to all of our students. I also want to recognize and publicly thank several people that were instrumental in putting this day together. First and foremost, the dedicated staff of our graduate education office, including Ms. Deborah Nordine, back in the area over there. Grace Vilar, who is unseen and hiding, running the projector in the back. But Cheryl Thompson, somewhere out there buried in the nutrition section. Oh, there she is. And finally, just a huge shout out to Milana Bay. She puts in countless hours of effort, stress, sweat, laughs, and occasional frustrations in making this a very special day for all of us and all of you. Thank you, Milana. The students of the Biomedical Graduate Student Organization, they are such a tremendous help and just an excellent organization and something you should look to get involved in. Dean Davis, who unfortunately could not be here today, for the financial support for this ceremony and for embracing the concept of Seeds of Discovery. And I want to thank and recognize our past graduates, parents, and benefactors from the community who have financially invested in our programs that help support this ceremony, as well as the eventual establishment of a PhD endowment fund. Finally, if you would all kindly take a few moments to fill out the brief survey and the guest information cards that are in your program. We are always looking for input to continue to try to improve the Seeds of Discovery event. And the completed surveys and cards can be placed in the blue boxes that are around the various tables. Please rise for the exit procession. I would like all of the entering PhD students, as well as their chairs and GPTs, to follow Dr. Chance and myself out in an exit procession, and we're going to immediately go out to the library lawn, everybody, graduate program directors, chairs, and students, to take a group shot for memory. Thank you all again. Thank you for coming.